Hello everyone. In this particular video, I'm going to tell you about the problem related to bit manipulation, that is copying the number of set bits in a range. Copy set bits in a range. Now, as you all know that as I mentioned it also in my bit manipulation video, that this set bit is your ones, the ones that you call as set bits. So if I write here like a particular number, suppose 8. So 8 in binary is like represented in what kind? 8 in binary is represented like this, 100. So now in this particular question, you will find that here the set bit is at the index 3. Now how we mention index in the bit format? When we write a binary number, then index is from right to left. That is 0, 1, 2, and 3. So this is the method of index. Now, if I suppose ask you that at which index in the eighth binary representation is the set bit, so you will simply say the third index. So now the question that is supposed to be solved here is that copy set bits in a range. Now, what is the problem statement of this question? So the problem statement is like that you have got one number x and you have got another number y. These are not the question marks, these are the given quantities. Let me just write it clearly. You have got x and y as the two numbers, and you have got a range here. And range is like that one is the L and one is the R. Now L and R here simply means left and right. And here you have got both are inclusive. Inclusive means that particular range is inclusive. Like you have to use the boundary elements as well. You have to take them into consideration. So again, I repeat, you have got two numbers, x and y, and along with that, you have to, and along with that, you have got a range as well. Now, range is clearly like that. It can be 2 and 3. It can be something like that. And then you have to do what? Keeping this index in mind, that is this particular index in y, you have to search from that index to that index, and you have to find the number of set bits. The number of set bits, like you have to find at which places the set bits are there. Simple. You have to find at which places the set bits are there, and then in X, if at those index or at any one of those or two of those indexes, if the bit is not set, then you have to set it. Simple. You have to do what? Again, I repeat, keeping this range, the given range in mind, you have to find the number of actually the number of set bits. Now, you don't have to simply count. You have to do like this, like you will be writing this particular number in binary form, and there will be some like it will go from one index to the other, that is 0 to at some index. And now this range, that is L to R, you will find, and you will find here simply like how many set bits are there at which places. So you have to get those set bits or at those same indexes, and then you have to put this particular x. Also, like the number x will be there, and it in binary representation, if you find that at those indexes at which the y has got set bit, if any one of those or at all those indexes x hasn't got the set bit, so you have to place those set bits at this particular index in x. Now, for an example, I'm telling you here, like for example, you have got x is equal to 8, y is equal to 7, and then you have got your range L is equal to simply 1, and your R is equal to 2. So if I just simply tell you about the range, so your range is 1 comma 2. This is your given range, and you have got two quantities as 8 and 7. So what you have to do, keeping this range in mind, you have to find in y. So the binary representation of y is equal to 0, 1, 1, 1. Now, index, if you start indexing from right to left, then this will come as 0, 1, 2, and 3. So 1 and 2 are this numbers. So 1 and 2 are these numbers. And now you find that. So you have to take like you have to make if you find that in y, this is y actually, this is 7, so this is y. So you find that at the index 0, the bit is set, at the index 1, the bit is set, and at the index 2, the bit is set. And when you write 8, as simple as that, when you write 8, so how you write exactly 8? So if you write simply 1, 0, 0, 0. This is actually the binary representation of it. And now you find that in 1 and 2, you have to actually take this particular range. So you have to do something that this particular range, the set bits, in our range, the set bit should come in a particular value, and then using a particular operation like and or, you should get here. So you know that you have inside 8, you haven't got the two bits here set. So you have to make these bits set, as simple as that, isn't it? You have to make these bits set. So how do you do that? So in order to do that, we will be doing what? We have to get here something called as mask. We have to make a mask here. And how we make a mask here, just simply get. Your 7 was something like this. And in order to get the mask, we all know that if we want to get the set bit inside a number, like from a number, if we want to get the set bit, then we use 1. And masking is done with reference to always 1. And how we can get those set bits? Suppose if at 7, the set bit as 1, and you want to get a 1, so first you have to get the mask, and then you have to do the and. So if you do the and operation, so and will result into what? Wherever two ones will come, only at those places it will return simply 1. So keeping this property in mind, you have to do the masking. And masking, how do you do? Let me tell you. So if you write 1 in binary, like 4 bit representation, so 0, 0, 0, 1. And then you have to do what? Now, firstly, you have to reach here. Like you have to reach the difference of this. You have to shift. So how do you shift it? You have to shift like 2 minus 1, as simple as that. So you do the simple thing. You shift it like the proper process is like that. First, you shift the number by r minus l plus 1. Because in a range, if you want to get the number of places that you have to shift, then it is always max minus min plus 1. Remember this. If you want to get the number of steps that you have to cross, then you have to do this. It's not the difference of the range, it's simply the number of steps. So firstly, you will do this. This we are creating as mask. This is not the final mask that we are creating. So if you just do simply this, so here what is coming here? Here R was 2 and L was 1. So what will come? It will simply come as 2. Like minus 1 and plus 1 will get cancelled out. So you have to shift 1 by 2. So what will 1 become? 0, 1, 0, 0. You shift 1 by 2 places. Now you will be doing what? You will be like 1. What you did up till now? You did like this. You did like this. Now you will be doing what? To this whole mask, you will be doing minus 1. So minus 1 will make this mask what? Where 1 was there, it will make 0, and rest where 1. Like this. Then you have to do what? Then you have to simply like the lower index, that is your left index. Left index was what? That is 1. So you have to do 1 minus 1. That is, you have to take it simply 0. So then you have to shift it by 0. That means you have to do nothing. Like after this is done, then you have to do it. Then you have to again left shift it by L minus 1. Now here L minus 1 became 0, so you have to do nothing. But in a general case, I'm telling you. So here it became 0, then this is your mask. Now, if your mask is ready, like I mentioned it also here, that this is your mask. If your mask is ready, then you simply do what? You simply, now in order to get the set bits, what? In order to get the set bits, what you have to do? You have to simply AND it. Like if you want to take the set bits at particular index of a particular number, then using AND you can only get, because wherever one is there, AND will only get that particular one. So what I'm going to do? I'm going to do here Y and now in order to get the particular places at which y has got set bit in the given range, then we will be simply doing, remember this, in the given range. Then we will be doing here y and mask. Now, what will be the output of this? So we will be going here. This is your mask. So this is your mask. Mask is what? Mask is simply 0011. 0, 0, 1, 1 is that. And what is here? Your y. So y was, I think, basically your, I believe, 7. So 0, 0, 1. What is y? Y is 0, 1, 1, 1. Now what will AND do? AND will simply give you the output here as 1, 1. This will be 0. This will be 0. Now, this is your output. Now, finally, in order to place this bits, like these were the bits set bits in the given range of y. Now, if you want to place those set bits, if they are not given in the range inside the particular number, then you can, and the other bits shouldn't change. So you have to simply use the bitwise OR operator, and it will do what? You have to do here X or P. P was here simply, if I write here, it was simply Y and mask. Simple. So X is here your 1, 0, 0, 0. And if you do OR with what? 0, 0, 1, 1. If you do here, then what output will you will get? You will simply get 1, and then you get 0, and then you get here 1, 1. So, which is simply equal to 11 in decimal. Remember this, which is simply equal to 11 in decimal. So, this is the process what we are doing. And now we straight away go to the VS Code, and you will get the idea of that. So how we are doing here? This is clear. So this is clear. Then we are using copy set bits is a function in which this is the first number, this is the second number, this is the left range, and this is the right. Like in other words, you can call this is min, this is max. And here is the int result, because I'm making a function here integer, so I have to return a result in integer. Now suppose if I have taken here the constraint, so this constraint does what? Let me explain you. This constraint simply limits the input in the int data type. So it does what? It just simply limits the input from the user in the range of, like, it should be in 32-bit. Like it should not be in more than 32-bit. Simple. So L and R will maximum go, if it is an integer element, it will simply go from 1 to 32. And if it is not so, so it will simply return -1. And why -1 I have taken? Because I have to return obviously an integer value. And else I have taken m1. M1 here is mask. So instead of writing the whole word, I have written m1 is mask. And then m1 I have done what? Firstly, m1 has been left shifted by r minus l plus 1. Then on this whole, I have done minus 1. Then on this whole, I have done L minus 1. And in order to get the set bits at those given range from Y, I have done and finally I want to get the result. So I have done what? I have to place those set bits in those set bits if they are not present in the given range. If they are not present in the given range, remember in the given range in X, then I have to simply place them in X, keeping other bits unchanged. So that can be done with the help of bitwise or. Then I have stored that particular result in or, and finally I've returned the result. And here is the parameter. I have taken 8, y equal to 7, l equal to 1, r equal to 2, and then the result is here. So I will just simply save this, and I will do what? I will run the code. So what will be the output? Let us see. So result, you can see here. Result, I have written here resultant, but you can simply write here result. So result is equal to 11. So our theoretical approach is also same, and our program is also same. So guys, that is it for this particular video, and it's a good question. And basically, it is there to clear your concept of masking, like how we have to do masking. I've also mentioned about masking in my bit manipulation video. You can check that out in DSA concept playlist. And hoping that you understood what we have to do in this particular question. So thanks for watching, and do like, share, and subscribe, and stay tuned for more content. Thanks everyone for watching. So I just want to tell you that for this particular program, your time complexity, since you are not iterating or you are not using any kind of loop or any kind of a particular statement which will run for multiple times. So simply the time complexity for this particular question, if I just tell you the time complexity for this particular question, that is copying set bits in a range, your time complexity will be big O of 1. And same will be your space complexity and auxiliary space. So that's all for this particular question. Hopefully you have understood it. So thanks for watching. Do like, share, and subscribe.